For the sake of constructing this music system as a purely mechanical one, let's take a gramophone needle, the old-fashioned one. Oh, let's draw here the vinyl, if you like, and the needle here moving from left to right, and this movement will move this membrane from left to right, and then this membrane is attached to either a gearbox or an hydraulic system, so that it will move this valve, the upper part of the valve, the sliding part, from left to right. I don't want to go into the detail of this section, but its role is to amplify the movement of the needle, which doesn't have the energy to move the slider from left to right. So it's also analogous to the driving section of the vacuum tube amplifier. Like this one is a sort of driving tube. Let's assume that this tube is placed at this point. The next thing we're going to do is to add a wing or a flap, if you like, which is covering the half of the tube and having an articulation at the surface of the tube, and which is able to move up and down with the waterproof. The down movement of this wing is easy to understand, but in order to make it move up, we're going to add a spring attached to the surface of the tube, fixed here, so that when there's this bias flow of the water, this spring is going to hold the wing in a balanced position like this one. So if there is less flow than the bias flow, the wing will move up. If there is more flow than the bias, the wing will move down. Now, if we attach the extending part of this wing to a speaker cone, like this, the speaker cone will move up and down. Now let's follow the hydraulic music system's operation from the source towards the speaker. Let's apply here a sine wave. Now, let's assume when the signal moves upwards here on the positive side, the needle is moving left, and this makes this valve, the upper section of the valve, move left, and which also allows more water flowing through this pipe, and it pushes the flap or the wing down, which at the same time pushes the speaker up, like this. So this is going up and the speaker is going up. Now the reverse situation is when the flow moves to the negative part, then this, let's say now at this time the needle moves right, this slider moves right, and there's less flow, and less flow means that the wing moves up, and when it moves up, the speaker cone moves down. So as you can see, this movement is translated here as an up and down movement of the speaker then we have our music system working. As you can see, a very small movement of the needle becomes a much bigger movement of the speaker. So the ratio between these two movements is called the gain of this amplifier. But where is the source of this water? It can't flow indefinitely as it is. So if we're not near a dam or an infinite source of water, this system wouldn't work. So we need to make it a working system, let's say a portable water system, water music system. So we need to add a collecting reservoir here, where this water flows and is collected and then pumped back to the upper reservoir. So the amount, assume this is an electric pump. This is the first time an electricity comes into the game, or we can make it also manual, but let's make it electrical. So this electric motor, and the kW that we apply here is the energy we input to our system, and it's depending on the water flowing through this pipe, the flow of the pump, and also the pressure. The height of this system determines the pressure of this pump. Therefore, pressure and flow determines the kW input of this pump, which is the energy input of our water music system. If we need to drive a bigger speaker, we need to increase the power of this amplifier. To do that, we need to increase the height of this water reservoir. Let's see, assume from 30 meters to 50 meters. Increase the pressure this way, and maybe increase the diameter of this tube, and therefore increase the water flow, and this will, therefore we can put a bigger wing and be able to move a much bigger speaker. But at the same time, we need to pump the water up from 30 to 50 meters and increase the water flow, and therefore increase the kW input. Nothing is for free. I hope the functioning of the water music system is clear for everybody. It can be made, it can work, but I can't guarantee the quality of its sound. Now let's move back to our triode valve. The plate, plus, and the cathode connected to ground, 0, minus here, and the grid. Now, because of the analogy of the grid to this valve here, the English or British people are calling the vacuum tube also a valve or a thermionic valve.